All right, in the last video, we succeeded in cubing the distance, squaring the period, and getting the ratio of them, and it looks like it's the same number for every planet except Mercury. Does that mean we haven't discovered a law that applies to all planets? There's something special about Mercury? No. The first thing you do if something like that happens and you go, wow, everything fits but one, you go back to your data. And if you look, I've actually input that number in miles, not kilometers. So if I fix it to the data I know, it's fine. If you're convinced you input your numbers correctly, you would have to go back and find out if the actual astronomer's data was right or wrong. But now we want to graph it. So we're going to go up to Insert and choose Chart, and it brings up this blank chart for us so we can graph this data. So the first thing we're going to do is move from a column chart to what's called a scatter chart. In math class, that's an XY graph. The first thing we're going to pick is which one of these goes on the x-axis. So I do this, and I can either type it in, or I can click and drag and pick out the period squared, which is going to be our x-axis. Then I'm going to pick out the first series, which is the distance cubed, and that will be the y-axis. Click OK. We get a graph. Sometimes it will decide to screw up this x-axis, right? So right now it seems to be doing it correctly. It's got B12, C2 to C10, and you're like, no, wait a minute, that's not right. It's gone ahead and forgot about the x-axis again. So I go in here to this, look at it. C2 to C10 is the series, okay? That's correct, but the x-axis went blank. It's something that's a flaw in Google Sheets. You've got to do the x-axis at the end, the series first. So I definitely want the period, the time on the horizontal. And click OK. Look at that. Could be a straight line. That's just for a legend. But we can't see anything because the bulk of the points are all smooshed together down here. So 1, 2, 3. The last 3 data points here, the numbers are so gigantic compared to the ones down here that it squished the graph in. So the only way of fixing that would be to get rid of those last 3 points. 7. 7. And why it threw in this B12 one, who knows why. It's glitchy. Now let's see what happens. Okay, now it's even worse. So we've got a problem. Like the scale break a while back, the numbers are too freaking big and small at either end to fit on the graph. So we can't see the result. There's a solution though. If we go down to customize and we go to horizontal axis and we go down here, it says log scale. What log scale will do is get rid of these gigantic numbers and replace them with powers of 10. So all of a sudden something happened there, but we got to do it on the other axis as well. Vertical axis, log scale. Now we've got a line of best fit. And if you notice the numbers here, these numbers aren't going up like 1, 2, 3, 4. Each time we go down, the number got 10 times bigger. You see what's happening? And so the log scale is another way of graphing things to take tremendously large numbers and tremendously small and fit them on the same graph. And what we see is as the length of the year grows bigger this way, the time it takes the planet to go around the sun is going up. And so this was Kepler's discovery, all pen and paper, that there was distinctly a complicated relationship between the distance to a planet's orbit and the time it takes. Now, there are some advanced possibilities here that you've got to locate, okay? And I'll show you how we can actually put the line of best fit on the graph. Okay, now we're going to do a line of best fit on here. We just go to Customize, and this series box here, you can open it and you can click Trend Line. And it makes an attempt to do a line of best fit. It doesn't quite match at the end. So the log graph would be better if you did the line of best fit by hand. But with the line of best fit on, I can sort of show you now that if you had a planet that was located at this distance from the sun, then you would expect its time to go around the sun would be this many days down here, which I can't read, it's too small. So if instead you found a planet at this distance to the sun and it wasn't orbiting at this time, but let's say instead it was orbiting at a much slower or faster rate, so it was getting around the sun really quick, there's only one conclusion. It's under thrust. Something's pushing it. And that would be a giveaway that we're looking at, maybe an alien spaceship or something. But nothing that's in an orbit has been ever seen that violates Kepler's law connecting the length of your year and the distance from the sun in this particular pattern. The last video I'm going to show you is strictly for advanced work, how to create the log graph on your own. None of this is testable, but it's there to show you that there are mathematical patterns we can find in the universe if you have no social life whatsoever and you have all the time in the world to play with your data and look for something that makes sense.